All right, we're going to graph square root function. And just to get started, before I even look at this first one, I'd like to remind you of things we've already done. Y equals A times the absolute value of X minus H, quantity plus K. What did the H do? I'll give you a hint. Shifts it right or left horizontally, K up or down vertically, and A stretches or flattens it vertically. Or if A is negative, it flips it over. You need to start just constantly, just think of that. When you do a graph, it makes sense to you, whether it's where it went or not. Nice little pattern to be following. These will follow that pattern as well. The parent graph for these is the y equals the square root of x, which is simply a square root graph that looks something like this and goes through the origin. All other graphs will be related to it. Y equals a times the square root of, oops, I made that way too big, x minus h plus k. Where again, there's shifts of the graph. This is the parent graph. This is a shift of the graph. Stretches, A stretches or flattens, H shifts it horizontally, K vertically. So a function that contains the square root of a variable expression is a square root function. That's what they're called, the square root functions. The domain of a square root function is those values for which the radicand is greater than or equal to 0. So as soon as you look at one of these, you can determine your domain by taking what's under the radicand and setting it greater than or equal to 0 and solving. That's where they added, they set 3x minus 2 greater than or equal to 0. They added 2 and divided by 3 to get x is greater than or equal to 2/3. That's where that came from, which would make your domain be from 2/3 to infinity. Okay? So once you find the domain and you sketch, you can tell what the range will be. So this is a table values feature. You can use the table feature on a graphing calculator. I'm going to show you how to do it all by hand. So let's graph the parent graph first off, which is the square root function. I'm going to make a t-chart or a table. First thing I'm going to do is say what's under the radicand is x, and x must be greater than or equal to 0. Whatever's under the radicand is got to be set greater than or equal to 0. That tells me right there the domain is from 0 to infinity. So I already know my domain. It's inclusive of the 0 and it goes to infinity. So that's interval notation for your domain. If I start to plug in some values, the square root of 0 is 0, the square root of 1 is 1. What would be the next logical number to put in if you're going to take the square root? 4. The square root of 4 is 2. Okay, now I've got 3 points, which is the requirement. You must have 3 accurate points on your graphs. 0, 0, 1, 1, 4, 2. There's another one we can see on this graph. Yeah, how about we do 9, square root of 9 is 3, 9, 3. And we would have all the points that would fit in the coordinate plane that we were provided to graph on. Now it is a curve, guys, so make sure it looks like it curves. Mine's kind of not the best, but... And then it keeps on going forever with an arrow. The domain then is from 0 on up. So the domain, excuse me, I said the domain. The range is already determined, 0 to infinity. I'm like, did I just dyslexic again on that? I just went backwards again. All right, domain, what x can be, is from 0 to infinity. The range is restricted to also 0 to infinity because it's going to keep getting higher even though this looks really flat, but it does include 0 up to infinity. They have the same domain and range for this particular graph. Number 2, y equals 2 times x. We're going to find out what happens underneath the radical. But first step is, say 2 times x must be greater than or equal to 0. If you divide by 2, you get x is greater than or equal to 0, which gives us a domain of from 0 to infinity. Next, I make a t-chart. I pop in some numbers that make sense to take the square root of. If I put in 0, I get 0. I always want to put in the first number in the domain. If I put in 1, that would give me something icky. It would give me the square root of 2, which I do not know. So I'm going to put in 2, because then I get 2 times 2, which is the square root of 4, and that's 2. And then, let's see, if the next perfect square is 9, do you guys know what I'm doing right here? I'm trying to think of numbers. I'm trying to get these numbers under the radicals, 0, 4, 9, 16, whatever. If I put in 2, I got 4, then I could take the square root of it and get 2. If I put in 4.5, I would get the square root of 9, which is 3. And if I put in 8, I would get the square root of 16, which is 4. We got enough points. You only need really 3 of those. And then 8, 4. So you don't have to do 4. You have to do 3. I just thought it was easy enough to see that 8 would have been a good one to put in. If somebody didn't choose to do the 4.5 one, that would be fine. They could have these 3. Okay. All right, so the range on this is also from 0 to infinity. I think that's all it asks for us to do. Y equals negative x, the opposite of x. The opposite of the square root of x, I should say more clearly. Well, this one I'm going to need to think about what this negative does out front. Is it going to change the x values, or it's going to change the y values? Yeah, the y's are what these equal, right? So this being the opposite is going to change the sign of the y's. So this will actually do something interesting. It will reflect it, and we'll see what it's going to reflect over. If the y's change sign, then if it's going to reflect over the x or the y-axis. If the y's change sign, and they were positive, they're going to become negative. So it's going to go over the x-axis. That's what that negative does. Looks to me like the points will all be about the same. X can be our domain. X is greater than or equal to 0. Will still give me a domain from 0 to infinity. Yeah, my pen stopped working there. Paused on me there. Okay, that was inclusive of the 0. So I'm going to go 0, and I get 0. Put in 1, I get negative 1. Put in 4, I'm going to get negative 2. Because you apply the sign after you take the square root. So I'll plot these. And I could try maybe 9 if you want. And I put in 9, I get negative 3. But that's enough. And we were right. It reflected over the x-axis. Oh, and the range is not 0 to infinity this time. It's going to be from negative infinity up to 0, inclusive of 0. Okay? Number, what's it going to do if the negative sign's on the inside? Is that going to affect the x's or the y's? Now it's kind of messing with the x's, isn't it? So that's going to change something about our domain, because we're supposed to say negative x is greater than or equal to 0. If I want to solve that and divide by negative 1, I have to flip the sign, so x is going to be less than or equal to 0 this time. That means they're going to be negative values for x. Why would they have to be negative? Well, if you put a negative in, you can't take the square root. If you put in positive 1, the square root of it would be the square root of negative 1, and that's imaginary. Okay, so you have to put in negative, so you end up with numbers to take the square root of that are positive. Okay, that's why it makes sense. I hope that you're going to stick in negative values. Let's do it. All right, our domain is from negative infinity to 0. I'll put in a negative, well, I can't put in negative 0, so I'll just put in 0. And I get 0. If I put in negative 1, I will get the square root of 1 as 1. If I put in negative 4, I'll get the square root of positive 4, which is 2. So this is what this looks like. And if you put in negative 9, you'd get positive 3. Now, look what happened. This didn't reflect over the x-axis like when it was outside of the radical. It reflected over the y, yeah. Now, I'm not testing you on that yet. I'm just asking you to try to start thinking about it and make, see what you can remember as we go. It will start to become more and more important as the course goes by. All right, number 5, we've got, x is going to be greater than or equal to 0. There's nothing else under the x, the radicand. So we've got a domain from 0 to infinity. We'll find out the range, probably 0 to infinity, but let's look. Oh, there's a negative 3 out front. So if I put in 0, I get 0. If I put in 1, I get negative 3. If I put in 4, I get negative 6. And I'm going to plot them. Oh, look how, doesn't that make that stretch a lot faster? If I put in 9, I'd get negative 9. And this thing is stretching down much quicker because of the multiplication by negative 3. So it actually reflected over the x-axis and stretched vertically by 3 times. So the y's went up 3 times as fast in value. It's almost like multiplying the y values by 3. Well, negative 3 in this case. Domain, I already wrote was negative infinity, infinity. The range would be negative infinity up to 0. Okay, do you have this? Okay, now on to number 6. So what do you think, where is the shift going to be? This graph of the square root is going to shift left 1. Remember, it's minus 8. What would this do? That one's horizontally. This one would be vertically down 4. Now, just to get, so we start getting more and more comfortable with those shifting ideas, let's go left 1 down 4 and make a point. Okay. Now, let's test it out. X plus 1, what's underneath the radicand, is supposed to be greater than or equal to 0. Solving that, you get x greater than or equal to negative 1. Which means you would want to start with negative 1 being plugged in, which would give you 0 minus 4, which is negative 4. Oh, look, negative 1, negative 4. That's where we started. The domain is from negative 1 on up to infinity. We'll figure out the range in a moment. I'm going to plug in some more numbers. Since I already know it goes negative 1 on up, that makes sense to plug in. If I put in 0, I would get the square root of 1, that's 1. 1 minus 4 is negative 3. So there's the next point I'm planning to plot. I think I'll put in 1, oh no, square root of 2. I think I'll go up to what makes sense. Yeah, because 3 plus 1 would be 4. Square root of 4 is 2. 2 minus 4 is negative 2. Well, this isn't going up very fast. And then, I don't know. If you wanted to get to 9, I'd have to stick in an 8. Square root of 9 is 3. 3 minus 4, negative 1. I still haven't gone over the x-axis. Oh, it's hard to make that look like a curve, isn't it? Okay. Oh, and I've got the range now. What can tell you what the range is? You may see how to get it or have it help. What number would be related to the range? The K, like before. -4 to infinity. Hard bracket on the -4. Always a soft one on infinity. Okay, we're going to stretch vertically. This is going to be a vertical stretch. 3 times. It's going to go up 3 times as fast as normal. The x minus 1 has to be greater than or equal to 0, so x has to be greater than or equal to 1, giving us our domain from 1 to infinity. Our range we'll figure out. Okay, do you have questions about how I'm deciding what to plug in? You can plug in other stuff, it just won't give you the nice answers. Let's see. Let's start with 1. We can't put in 0. The smallest is 1. That gives you 0. I could have said this is a shift to the graph to the right horizontally 1 unit. And that's what just happened. Boom. Shifted over right to the 1 unit to the right. I'll start putting in some other numbers that make sense, like 2. 2 minus 1 is 1. Then I'd get 3 when I multiply by 3 after I took the square root of 1. If I put in 5, 5 minus 1 is 4. The square root of 4 is 2. I'd get 3 times 2, which is 6. And I'm just saying out loud what I'm doing for my mental math. We're going up pretty quick here. This is suspected. To put in 10. 10 minus 1 is 9. Square root of 9 is 3. 3 times 3, 9. 10, 9 would be the last point we could fit on here. There it is. All right, so what's our range? Come on. The range. Yeah, 0 and up. Okay, try number 9. Okay, so that negative sign reflects over x-axis. This is a horizontal stretch, or not stretch, shift right 2, and vertically up 4. So I'm going to see if I can start at 2, 4. If I put in 2, because their domain is from 2 on up, minus 2 zeros, I get 4. Oh, goody, 2 4s, where I had a dot already. 3, give us 3. Putting in 6, would give us a 2. And that's probably enough. Otherwise, you got to put in 11, right? Okay, so that's what the graph should look like. Something like that. Mine's kind of squiggly. And the range would be from negative infinity, oops, up to 4. Uh-oh. How are we feeling on that? Okay, does anybody need help with how they did that one or more explanation? All right, then try 9. Sometimes you guys are often just copying and you're not really thinking about what I'm saying, and I know that can happen. So let's try to remember now. The first step is to say what's under the radical and go x that needs to be greater than or equal to 0. You will be getting this much faster if you start listening to that piece. You solve it by adding 1. So the values of x must be greater than or equal to 1. That tells you your domain right away. 1 to infinity. That's what that means. And you make your t-chart. Put in a 1. Whatever this says, the first number. You'll get 3. Then 1, if I put in 2, that would be okay. 2 minus 1 is 1. Square root of 1 is 1. 2 times 1, 2. 2 plus 3, 5. Put in a 5. 5 minus 1 is 4. Square root of 4 is 2. 2 times 2 is 4. 4 plus 3 is 7. Okay. Range from, what's that low point? 3 to infinity. Okay, try 10. Okay, this should be the answer to what you got for number 10. And the range is from negative infinity up to 0. I just started recording again. Okay. Last but not least, oh my gosh, this thing's going to be really flat. That's going to flatten the graph. It's going to go up even slower than it already does. Nope, I can't do that. Give it a shot. These are kind of icky, some of these numbers, don't they? Even though, because if you put in negative 1, square root of 1 is 1, half of that's half. 1 half minus 6 would be negative 5.5. This thing's like barely moving between points. Put in 2, that'd be negative 5. So you're still here. What's good to put in? Where to be? 7? 3 halves, though, minus 6. 1.5 minus 6 would be 4 and negative 4.5. This just doesn't move much. Very small increments as it goes. But the domain is going to be negative 2 to infinity. And the range is going to be negative 6 to infinity. Even though it looks like it's not even going up at all, it is. Okay, this was our last lesson of the Unit 1. The next step is for us to answer questions, or myself, to answer questions for you. So we'll have work day / question day tomorrow. And we'll begin reviewing for the unit test, which is going to be after your 4-day weekend on that following Tuesday. So the next 2 days are work and review days. Hope that makes you happy. All right, I'm going to close out my recording. Timer's out for now.